And so from this point on, throughout the class, unless I stop the recording for some reason, it will be recorded and posted on YouTube later on. All right, so you're in pretty good shape. Now, a question that's come up very frequently in the past, I don't know, the gallery view of Zoom, like the faces and the names and stuff like that, that doesn't show up. All right, so if you're worried about that, then you don't need to. All right, if you're very hesitant to have your voice in a recording, then you can put a question through the chat if you want. All right, and we can go that route. All right, so just some thoughts. Anyway, we're going to start off with a review of domain and range and other types of notation, just because it's really kind of a foundational concept when it comes to calculus, which is ultimately where this story should end, you would think, but not necessarily the case. What we need to be able to do is kind of develop the language in which we could all speak mathematics. All right, so we have some definitions. A relation is a set of ordered pairs. The set of the first components of each ordered pair is called the domain, and the set of second components of each ordered pair is called the range. Kind of a weird thing to say. It just seems very vague and not very meaningful. But if I tell you that you have, for example, a coordinate set of 1, 2, 3, 4, and 5, 6. Put it in squiggly brackets. Just kind of move this over a little bit. So let's say you have this ordered set of coordinates, right? Each one of the x values would make up the domain. So the domain, maybe in astrology. Domain would be the numbers 1, 3, and 5. The range, because the domain is the first entry in each ordered pair, the range would be the second entry in each ordered pair. In this case, 2, 4, and 6. All right. If it's a simple list of values, then you would just indicate what those values are without any repetition. Like if the number 3 occurred 7 times, you still only write it once. But you would just write a simple list of individual values. Now, if it was everything, the domain was every value between 1 and 10, for example, including all the decimals, then you would say something like going from 1 to 10, you get into your interval notation and your inequality notation, which is what we're going to talk about in a minute. But if it's a simple raw list of data points, it's really just a matter of just indicating what each of the x values are and the corresponding values of y. Right? And so what you would be looking at graphically, so I said I wasn't going to get into the Desmos right away, but now I just kind of can't stop myself. You'd be looking at just ordered pairs corresponding to points on a graph, right? Not connected, just points in space. All right, so that's what the graph of these 3 coordinates would look like. Right, nothing too fancy, but one thing you wouldn't do is connect the dots. All right, that if you're given a raw set of data points, then your actual function or relation is just going to be that raw set of data points. Right, but we want to get into cases where it basically exists over an interval. And so we represent it in a variety of different ways. One way you could represent a domain or range, we're going to focus mostly on domain, would be in words. Right? You just keep it simple and say it goes from here to there. Pick a number between 1 and 10, and then you invariably have that conversation of, well, do you include the 1 and the 10 or not? And I say pick a number between 1 and 10. Okay, 1.75. Oh, okay, I meant an integer or a whole number. So these are the kind of vocabulary terms that come into play, not so much because I want to be difficult and annoying, but more so that I can have a common language to discuss mathematics. All right. So that's the importance, or the most basic element of the importance of it. So we'll start off with interval notation. It's a skill, getting from interval notation to inequality notation and the other way around. But you'll find that as time goes on, you'll develop kind of a preference for one as opposed to the other. And invariably, you'll prefer one, but you'll be required to write it in the other. Right. So you'll be like, oh, I really like interval notation. And the teacher will be like, well, I want my answers in inequality notation. You're like, dang it. Right. And vice versa. Right. But if you're writing in interval notation, always from the smallest to the largest term in the set, right, separated by commas. Right. So it's easy to confuse those with coordinates, but if you get the hang of it, it's not that bad. Parentheses exclude values, right? And brackets include values. The exception, it's not really as much of an exception as it is just an extension, is that infinity or negative infinity always get parentheses. When I say get, I mean the type of fencing that you would use to bound infinity would be basically the kind that would not be able to bound infinity, because you can't actually include, because parentheses exclude a number, you can't include a value that you can't capture. Right? Infinity is always on the move. Right? So if you have, like what you perceive to be the largest value in creation, I can always just add one to that and get a larger number. Right? And so because of that, we're looking at something that's not finite. Well, duh, because it's called infinite, infinity. But it's not something that's capturable because it's never standing still. Right? So you got to kind of think of the infinity as a moving target. How can you capture, how can you bracket something in if it's always moving away from you? Right? You take one step towards it, it takes one step away from you. Right? So this table gives you kind of a rundown on how to write in inequality and interval notation. But what I wanted to do is take you through, a guided example rather than just kind of leaving it to you to study this. So on the next page, complete the following table. It's just a quick walkthrough on what an interval is going to look like in inequality form and vice versa. Right. So what I'm going to do is I'm just going to draw a quick sketch. All the sketches are here, but I'm going to draw it out for you. Might seem overkill, but I think it's a valid thing to do. So I'm going to draw a number line, and that number line is going to go from A to B, or at least it'll contain A and B. It'll go beyond it. All right. And maybe I'll put a negative infinity down over here, because if you could go on forever, that's where you get. Positive infinity, if you can go on forever in the right-hand direction, that's where you'd end up. All right. So what bracket A comma B means is that you're starting with point A and ending with point B. I'll go red for those keeping score. So everything in between would be part of that set. All right. So they're not given numerical values, so we wouldn't say anything more than that. Like A and a half, I don't know. It all depends on what A is, right? But if I'm starting with A and ending with B, if I'm writing it in inequality notation, I'd be basically saying that X is existing in between those two values, right? It's in the interval of A to B, right? All that red stuff is X, that's the variable, right? X varies between the value of A and the value of B. So I would start with A, end with B. X is in between, X is somewhere in between those two numbers, including possibly being A, including possibly being B. All right. It could be A, it could be B, it could be anything in between. All right. So the brackets correspond to an equality of some kind, whether it's a less than or equal or greater than or equal, but it's going to involve, in both cases, these are less than or equal, but it could be the other way around. And if that's the case, then you would have this kind of realization that anytime you see a bracket, you got to have something that has an equal sign. It's just a question of what, right? Whereas the second one, and I'm going to kind of shrink this down a little bit. And do a quick copy. And shrink that one down a little bit. And the reason I can do this is because they're very similar. Maybe you can go smaller. Super 10. And then I'm going to zoom in big time. All right, but I'll do that in a second. All right, so this one is going from, if we're focusing on the inequality notation, you see that it's very similar to what we had just written in the first one. Right? The only difference is we have a less than symbol rather than a less than or equal to symbol. Right? So the way that difference manifests itself is actually pretty straightforward. It manifests itself with an open circle. Right? So the only difference between the two ideas is that in the case where I had brackets, I would use closed circles for my endpoints. For parentheses, I use open circle for my endpoint. In this case, just a point singular. All right. So I'll make a little note there. That is because, oh, I said brackets and parentheses. I meant less than or equal versus less than. It'll also mean the same thing for brackets and parentheses, but I'll get to that in a second. Because less than B, not less than or equal to B. All right. So that's this piece right here. All right. So now we come to this idea of parentheses versus brackets, because if you look at the left-hand side of each of these inequalities, each of these compound inequalities, when you have a sentence that has multiple inequalities in it, we call that a compound inequality. That's made up of the same stuff. So my interval notation should be made up of the same stuff, at least on the left side. So bracket A, comma. But on the right-hand side, that's where the difference occurs. All right, right-hand side, that's where the difference occurs. And the difference is one has a less than or equal, which corresponded with a bracket, versus a less than, which would correspond with parentheses, the closed parenthesis. All right. So little note, it's up to you if you need to write this. I mean, you either knew this coming in or you didn't. Or I guess the third possibility is you knew it somewhat, you just need a little brush up. What I would write here is greater than or less than, get parentheses, I don't think, parentheses. And open circle. Greater than or equal or less than or equal, get brackets and close circle. All right. The difference being, you know, what we're using it for. So parentheses, as we write it in interval notation, the open and closed circle is when we represent it graphically. All right. So then you look at the next one, you say, okay, well, wait a minute, I think I got this under control, or maybe you don't. If you don't, then listen up, because this is where you're going to hopefully get it. That A has parentheses, right? Parentheses correspond with a greater than or less than symbol, and graphically an open circle. I was only using the graph to support the knowledge or the understanding of how to do this stuff. We don't actually need to draw a graph, right? But if you see here, in each of these two cases, we had A less than or equal to X, which corresponded with a bracket. So in this case, what I want is A not less than or equal to X, but just less than X. Because again, the parentheses go along with a less than symbol. The bracket goes along with a less than or equal to symbol. And so that justifies why we would write less than or equal to B. All right. If you just do a quick comparison, you see that we have a bracket B, that coincides with less than or equal to B. Right. Whereas any instance in which we would have a parentheses would correspond with a less than symbol. Right. So A less than X less than B. Graphic, I'll just do a quick graph on that one, right? Because that's somewhat dissimilar. I mean, same ingredients, but it just has enough of a difference that it's worth having its own conversation. In this case, you see that we have a less than symbol for both A and B. So we would represent that as A comma B in parentheses. People get confused by that very often. When you see A comma B, or like 1 comma 2 in parentheses, now you have to be thinking, am I talking about a coordinate or am I talking about a domain, right? Because the context is going to be meaningful. Because over here, 3 comma 4 meant the point 3 comma 4, all right? But over here, if I wrote 3 comma 4, I'd be talking about all the values in between 3 and 4, all right? Graphically, that would look like, I'm going to say this in a second, but my timing is a little bit off. Delete. Oh, I just jammed myself up. I couldn't even find my marker for a second. So that would look like this, open circle to open circle. All right, and everything in between. Or just everything in between, really. All right, so everything in between 3 and 4. All right, so it's kind of weird, definitely a little on the tricky side, but I can, and I'm sort of kind of getting ahead of myself here, but I'm gonna just take a second and show you a little bit with Desmos, because this is kind of like the time to do it. But it's not anything, or at least what I'm about to show you, that you'd be really required to do. I just figured, why not? And it's pretty cool. So you might remember that I mentioned that you're not required to purchase a TI calculator just because my stock phrase now is I don't like spending people's money for them. Right? So you don't have to get it, but you got to use something graphing calculator wise, and so that something should be the Desmos calculator, right? I think anyway. There's other calculators out there, but this is the one that really kind of ties together with all the math that you would be learning in the next series of courses. So you go to desmos.com. You can see that at the top of the screen there, hopefully. Desmos.com, create an account. I'm going to show you really quickly. If you look at the full website, it looks something like this. You'll see graphing calculator as the main tab there. You'll also see math tools, graphing calculator, scientific calculator, and so on. You'll find that as you go through, different curricula, whether you're taking just all all the calculus, pre-calc and calculus, or maybe you're just going on to a stat class or something like that, you'll find that there's a little something here for everyone, right? But we're going to be living in the graphing calculator, right? I'm already signed in, but in that home screen, you can create an account. If you have Google, which most people either have Google or an Apple account or a Microsoft account or something like that, you can use those credentials to sign in and link it to that. All right, so that's just something to keep in mind. But one of the reasons why I wanted to show this to you is because you can actually create a variety of different expressions using Desmos, and one of them would be something along the lines of, if I wanted to graph A is less than X, I can type that in and then click on the slider to give A a value, and it'll show me what the graph would look like depending on that particular A value. Right? So it's kind of cool to get a sense of what it is that we're actually working towards here. But I can also take it a step further and say it's also less than, for example, the last one we did was A is less than X is less than B. I can create a slider for B and get an idea of just what's happening when A is a particular value and B is a particular value. Now you might notice there's some dashed lines, right? And dashed lines is another way of representing the absence of a data point, right? You're not including those numbers, right? But this gives you a good idea, hopefully, of what X values make up your domain, right? So I just figured I would kind of take you off on that little tangent real quick, because right now it's a tangent, but it won't always be a tangent. It's useful information. Just right now, it's just sort of for fun, right? But gives you an idea of just sort of the power of something like Desmos that kind of makes it worth our while, right? The visual aspect, right? But if I want to go from B to infinity, that's a little bit of a different story, right? So let me get a sketch for that one. So if I start off with some value B, I'll put B right here, and I want to go off to infinity, which is somewhere in this, very far to the right. And that B has a bracket on it, which means that there's a solid point. I'm talking about all of, and let me go red now. I'm talking about all of these points between B and infinity, right? Every one of those values on this interval is going to make up the set of possibilities for X. Any one of those could be X. X varies between some number B and infinity. All right. So you got to kind of think about, okay, well, what does that mean? Well, if a point is to the right of another point, that means it's larger to that point on a number line. So if I have a point, this point over here, 5, 0, that's to the right of this point, -3, 0. You see how that 5 is bigger than the -3, right? Anything that's to the right of another point on the graph is going to be larger in terms of X, right? So what I want to say is that X is going to be larger than B, but also I have to take note of the fact that it's a solid point because of the bracket, right? So it could also be equal to B. So what I would say here is that X is greater than or equal to B, right? Because X could be anything larger or the same as B. And the way to represent that is with a greater than or equal to symbol, right? So hopefully this is seeming familiar. I know I don't know how to say this without sounding like a jerk and without sounding like I have a superiority complex or even that to simplify that, I just think I'm better than other people. Because in a lot of ways, of course I am. But in a lot of ways I'm not, so everybody's got their strengths and weaknesses, right? But so that's my preface for saying that I think some teachers skip over this topic because they don't know how important it is for the later courses. And that if you have never seen this before, it's because your previous teacher incorrectly thought this wasn't important, right? And maybe because they just didn't have enough experience to say that it would be important. I know that there was a point in my career where I was like, why does this even matter? And not just for this topic, but for other ones, right? But it's critically important. And so we don't want to just kind of gloss over it. So hopefully you've seen it a little bit before, but if not, hopefully this is helping someone. So the next part, we just came up with x is less than or equal to b, and that corresponded with b with a bracket. So x, I think I said less than or equal. I meant to say greater than or equal to b. X is greater than b would then correspond with parentheses b comma infinity. You'll never have to worry about brackets versus parentheses on an infinity because it's always parentheses every single time. So you don't have to worry about that. All right? You just got to think about what is the direction of the graph, right? Is the point that you're given, the B, the A, the largest or the smallest point, right? Or are you looking at a set that's in between two values? All these different possibilities, but once you get some experience with it, you realize that there's a very small set of possibilities and you can get a handle on it pretty quickly. All right, negative infinity to A. Let's do a quick sketch for that one. With A getting, A has parentheses, so A is going to get an open circle. All right, so we're looking at everything to the left of A. All right, everything to the left of A. Okay, so what does that mean? Well, same as it meant before, except same but different. It's the reverse. Color. So I want my x values. X occupies all the values that are in between negative infinity and A, excluding the negative infinity because you can't capture something if it's on the move, and excluding A because they said so. All right. But what this really means, because x is to the left of A, any possibility for x, because x varies, anything that x could be, regardless of what it could be, has to be less than the value of A. Oh, and there we are. All right. So if you talk it out a little bit, that's assuming you don't get it immediately, then you can kind of like sort of convince yourself of what the correct answer is. And so it's a little bit easier, I think, that way. But I don't know, some people just don't like talking to themselves as much as I do, I guess. That's a possibility. Below, you see a few examples, numerical cases. I figured I'd start off with the general stuff, walk you through a table, and then give you some numerical stuff. And now we'll just do a quick example related to just some numerical values, just to kind of drive this point home. All right. So the example below, I didn't give a graph because I'm going to draw one here in a second. Specify the graph set in words, set builder notation, and interval notation. All right, so let me just draw a quick little graph here, just the number line. All right, and let me put a 3 here, a 5 here. I'm going to go with red. And I'm going to go with an open circle over here, also staying with my red. try and make this look halfway decent. Get rid of this arrowhead here. I guess it's a little bit better. All right, so I'll just chuck in a negative infinity on this end and a positive infinity over on this end. All right, so I have two different regions here, but based off the skills that we've been talking about, we should be able to put this together. All right, so in words, I'd be looking at this by saying, so I'll say, the words relatively straightforward. I'm looking at values of x that are less than or equal to 3. Right? So values of x. You see in the table above, we use h. It really doesn't matter. You'll know based off of whatever problem you're working on what your variable is. So don't get thrown off by a different choice in variables. There is a reason for some selections of h versus s versus x, but at this point it's just skill building, so you don't have to worry about it. All right, values of x that are less than or equal to 3. All right, so that's this set here. All right. Now, an alternative to that is that we could be looking at, or values of x that are, you could say more than, you could say greater than, above, I'm going to say greater than, than 5. All right, so that would be this set. All right, so it could be either or. It can't be, coinciding. You can't have values that are less than 3 and greater than 5 at the same time. Because if you have a value that's less than 3, like 0, that's not going to also be greater than 5. All right, so it's got to be one or the other. All right, so in the form of set builder notation, the first thing we do is we state the variable that we're using. So we open a set of squiggly brackets. We state the variable that we're using, in this case, x. And that was a choice. If they said h like above, wherever they are, well, I would write h with a vertical line. That vertical line means such that. Right? So that means such that or given that. Yeah, so it's a condition. It's saying that it's x, but only under these circumstances. All right. And all we would have to do here is write symbolically what we just said verbally. Values of x that are less than or equal to 3. So x is less than or equal to 3. Now, this one you might not be as familiar with. The symbol for or is a V. Right, it's a logical connective. Right, so you could always represent the word or with the letter V, but you could also just write or. Yeah, most people are kind of okay either way. I prefer the appropriate notation, but I'm not going to lose any sleep if you write the word or instead of using the V. All right. The other possibility is that x is going to be greater than 5. Now, if you're taking a discrete math class or anything involving logical reasoning, then you'd absolutely have to know that notation, but it's not as necessary. All right, so that's the set builder notation. Most people were probably pretty good with, I would think, the x is less than or equal to 3 part, based off the diagram, and the x is greater than 5 part. It's all the other business that throws people for a loop. All right. The squiggly brackets versus parentheses versus regular square brackets, the vertical line all of a sudden, meaning such that. You know, it's kooky, but it's building towards that common language of mathematics, right? And then the last type of notation is the interval notation, which was really the whole purpose of all of this. X is less than or equal to 3. So on my number line, that's telling me that I'm going from negative infinity to 3. Parentheses for infinity always. That 3 is a solid point, so it's going to get a square bracket. Okay. Then we're going to go from, kind of overusing the highlighter here. Let me get a fresh new one. I'm going to go with a light blue here for those people who scored home. Oh, now it looks green. This is heartbreaking. / awesome. The reason I say awesome is because that's an illustration that GoodNotes follows the rules of primary and secondary colors. Yellow and blue make green. Okay, so 5 to infinity is the next interval. Parentheses around both because we don't include the 5 in the set because that's what the diagram told us. And infinity gets parentheses because infinity always gets parentheses, whether it's positive or negative. All right. But we got this little gap here, this gap of nothing. All right. That is to be as confusing as possible, I guess, is going to get filled with the letter U. Right? If I can make a U. U. Right. That U represents a union. Right. We're uniting those two sets, but it's the interval notation version of the or symbol. Right. So both of those mean or. All right. Now, that U actually, it stands for something else. It stands for union, but a good working definition is we think of that as or. All right. So, yeah, I know I always feel like I'm throwing a lot at you very quickly, but technically it's all review. I just always feel for the people who've never seen this before, because it's like it was never your fault, you know, like it should have been taught to you, but it wasn't. And so now you're looking at all this symbolic notation, and we all know things are always easier the second time around. It just, you know, doesn't mean it's going to be easy. It just means easier. Just if this is the first time you're seeing this, it's kind of a lot to digest. But we're going to be revisiting this over and over and over again throughout the course, so it'll kind of build upon itself in terms of, and it's sort of like a muscle memory sort of thing. You'll be using it so frequently you won't even realize you've become used to it. That being said, there won't be a problem when we start reviewing for a test. There won't be a problem on the test saying specifically put this number line in interval notation. This process is going to be part of some other longer, that sounds terrible, but multi-step type of problem. All right. So there's good news and bad news, because sometimes we want the multiple choice, which of the following is the correct interval notation of this inequality, but that doesn't really kind of lend itself to this course. That would be more of a college algebra sort of question, right? So we're using this to help us understand other concepts down the line. So what I'm going to do, let me just stop this video.